Selamat pagi, selamat siang, dan selamat malam. Perkenalkan, nama saya Gerald Regis Simanjuntak. Di sini saya akan menjelaskan tentang dissolving pulp in paper and pulp industry. Untuk memenuhi tugas mata kuliah Teknologi Pembuatan Pulp 3 bersama dosen Pengampu Pak Chairul STMT. So this presentation explored the role of dissolving pulp in pulp and paper industry, highlighting its product, process, and application, challenges, and future prospect. So dissolving pulp is a high purity cellulose product used across various industries, notably in textile, food, pharmaceuticals, and bioplastic. This presentation will be provided by the first is the definition and composition of dissolving pulp. The second is the overview of the production process. The third is key application and market trend. Fourth is environmental and economic consideration. The fifth is the process of the dissolving pulp making. And the fifth is, and the last, I will explain about when did this dissolving pulp will be used. So the first is the global context. Dissolving pulp demand is growing due to its use of sustainable alternative to synthetic material. Key production regions include in Asia Pacific, Europe, and North America. Major consumers are industries like fashion in rayon, lyocell or fabric, and packaging in bioplastic, and healthcare in pharmaceutical fillers. What is dissolving pulp? So dissolving pulp is a purified form of cellulose, typical with more than 90% cellulose and minimal hemicellulose and lignin. It is specialty grade pulp, distinct from paper grade pulp, which has a broader composition range. Primary uses include viscose rayon production, cellulose acetate, and food pharmaceutical products. The production of dissolving pulp began in the first of 20th century to support the textile industry. Initially developed for making rayon, its application have since expanded to bioplastic and food additive. Technological advancement have significantly improved yield, quality, and environment performance. I'm going to explain about the type of dissolving pulp. The first is pre-hydrolysis kraft pulp. This produced using the kraft process with a pre-hydrolysis step to remove hemicellulose, preferred for high-strength application like textile. The second one is sulfite pulp, manufactured through the sulfite process, ideal for high brightness requirements and often used in food-grade cellulose and pharmaceuticals applications. Okay, now I want to explain about the raw material for dissolving pulp. The primary sources, the first one is wood-based, like softwood. The example of softwood is pine and spruce, and the hardwood, the example is eucalyptus and beech. And there's some material also didn't uses non-wood material such as bamboo, baggage, and cotton linters. Wood-based material are widely available but require sustainable harvesting. So, non-wood sources are increasing popular for economic-friendly production. The production process. The first is raw material preparation. Start from chips or fiber, clean and size. The second is cooking and lignification. The third is bleaching. The fourth is purification. It is the final step to achieve high purity cellulose. So this I will explain about the pre-hydrolysis kraft process. So the step is pre-hydrolysis, high pressure steam, remove the hemicellulose. And then the next is the step of kraft cooking, which sodium hydroxide and sodium sulfite will add to the pulp in order to break down the lignin. The advantages of this process of kraft process is high cellulose purity and strength, and efficient for large-scale production. The application for this pre-hydrolysis kraft process is for textile, film, and cellulose derivatives. Next is the sulfide process. The step is the pulp will be cooked with acid sulfide chemicals. The, it will produce high brightness pulp suitable for specialty applications. There's some challenges in the sulfide process, such as there will be so much acid waste acid waste management and lower yield compared to the craft process. So the common users in the sulfide process is pharmaceuticals, food grade, cellulose, and high brightness product. So in this sulfide process, there will be environmental challenges for us in the sulfide process because we use acid waste. So the next is bleaching and purification. The purpose of this bleaching and purification is to remove residual lignin for high quality purity, high brightness cellulose. As we know from the cooking process, the composition of lignin will be a little. So in this bleaching and purification process, it will remove the rest of the lignin that will be residue in the pulp. The chemical that we use in this bleaching and purification is chlorine dioxide, oxygen, and hydrogen peroxide. Environmental impact by this bleaching and purification is shift towards elemental chlorine-free or ECF and total chlorine-free or TCF method to reduce harm. Application overview. So there is some application overview. The first one in the textile industries, the second one is in bioplastic industries, the third one is in food pharmaceuticals, and then the next dissolving pulp in textiles. Producer fibers like viscose and lyocell that are biodegradable and sustainable. Advantages of this dissolving pulp in textile is soft texture and high absorbency and suitable for alternative to synthetic fibers like polyester. So as we know, in the textile industry, we need materials that can absorb water to make yarn. The trend of this dissolving pulp in textile is growing demand for eco-friendly fashion material and also fashionable. Dissolving pulp in food industries. The first one is microcrystalline cellulose or MCC used for food additive for thickening and stabilizing. The application is baked goods, dairy products, and pharmaceuticals. Safety approved by global regulatory bodies for FDA and EFSA. Okay, now I want to explain about the process of making the dissolving pulp. The first is raw material preparation. The sources we use in dissolving pulp is typically made from hardwood, the example is eucalyptus, and softwood such as spruce and pine, and non-wood sources like bamboo, baguisse, and cotton lignans. So in this raw material preparation, we will chip all the log of the wood, and then we're gonna do the screening in order to remove the impurities to ensure consistent of the process, so that the efficiency of this process will be high. The next is pre-hydrolysis process. The objective of this pre-hydrolysis process is remove most of the hemicellulose and partially degrades lignin. The method that we use is the raw material is treated with high pressure steam or hot water, which break down hemicellulose into soluble sugars that are then washed away. The result of this pre-hydrolysis process is the material become more suitable for subsequent chemical treatments. The next is cooking and delignification process. So cooking and delignification process divided by two process is the first the craft process and the second is the sulfide process. The process uses a mixture of sodium hydroxide and sodium sulfide to dissolve lignin and leaving cellulose intact. The sulfide process uses acid sulfide chemicals to break down lignin. The outcome of this process is significantly reduced lignin content, isolating cellulose. As I explained just now about the craft process, will give uh, pulp that is high strength, but the sulfide process will give the brightness quality high, so that between these two process we need to know which process that we need, that's suitable for our end product. So the next is bleaching process. The purpose of this bleaching process is to remove any remaining lignin and change the brightness and purity of the pulp. The common chemical that we use in this bleaching process is chlorine dioxide or elemental chlorine free or ECF. The second one is hydrogen peroxide with the parameter is total chlorine free or TCF. Oxygen and ozone in modern environmentally friendly method. The key step, bleaching is often conducted in multiple stages to ensure the high brightness and minimal impurities. So this bleaching process will be done in like not only one step but oftenly in the pulp making process to increase the brightness of the pulp. The next is the purification and washing process. After bleaching, the pulp undergoes through washings to remove residual chemicals and impurities. Additional purification steps may involve enzyme treatment to achieve higher cellulose purity. The next process is a drying process. The purified pulp is dried into sheets or rolls for easy storage and transportation. The final product typically contains 90% until 98% of cellulose, and it is ready for shipment to industries that convert it into specialty product like viscose, lyocell, or microcrystalline cellulose. The next is environmental considerations. In this environmental consideration, there are some steps that we need to look for. The first is the effluent treatment, which wastewater from cooking and bleaching is treated to minimize environmental impact. So as we know, the cooking and bleaching process will using that much of chemicals that will give a bad environmental impact to the environmental, so that uh, after the effluent treatment we will need the chemical recovery. In this craft process, spent cooking liquor like black liquor is recovered and recycled to improve sustainability. And also, in this chemical recovery, it is used to minimize the cost, because as we know, the using of chemicals will make the cost will be higher. The next is energy efficiency. Many mills integrated heat and energy recovery system for process optimization. So the conclusion of this environmental consideration, some of that will lower the cost of the industry and also will be efficient for the industry. Next, I will explain about types of product that use dissolving pulp. The first is textile product. Dissolving pulp is extensively used to produce cellulose-based fibers for textile. The first one is viscose rayon. Viscose rayon is a semi-synthetic fiber used in clothing, upholstery, and industrial applications. The second one is lyocell, a more suitable fiber known for its softness, durability, and biodegradability, used in high-end clothing and householding textile. The third is modal, a type of rayon which enhances softness and absorbency, commonly used in a lingerie, bedding, and activewear. So as the three The three product in textile that use viscose, lyocell, and modal. Modal will be the most high cost in this using of dissolving pulp, because it will need a softness and high absorbency. The next using is bioplastic. So in this bioplastic, we use two type of pulp. The first one is cellulose acetate, used to make biodegradable films, eyeglasses frames, cigarette filters, and packaging materials. The second one is using cellulose-based composites, applied in developing eco-friendly alternative to traditional petroleum-based plastic. The third one, the using of the dissolving pulp is in the food and pharmaceuticals. The first one is microcrystalline cellulose, or MCC, used as stabilizer, thickening, and anti-cracking agent in food products like sauces, dressings, and baked goods. The act and exception in tablets and capsule in pharmaceutical industry also use microcrystalline cellulose. The next is hydroxypropyl methyl cellulose, or HPMC, used as a vegetarian alternative to gelatin in capsule and as a thickening agent in food. The fourth, in the film and packaging. In this film and packaging, we'll use two products. The first one is cellophane. It used for transparent and biodegradable film used for wrapping and packaging in food and gift industries. The second one is eco-friendly films, used in flexible packagings and biodegradable bags. The using of the next using of the dissolving pulp is in the industrial application. The first one is nitrocellulose, produced by treating dissolving pulp with nitric acid, with use in explosive, lacquers, and inks. The using in industrial application. The next is cellulose ethers, applied in drilling fluids, adhesive, and coating from construction and industrial purposes. The sixth is personal care product. So this dissolving pulp also will be used in personal care product like cosmetic ingredient, used in skincare product as thickeners, emulsifiers, and stabilizers. And the next, in the personal care product, the dissolving pulp will use to wipes and hygiene product. The soft fiber derived from dissolving pulp are used in baby wipes, facial wipes, and other hygiene products. So as we know, dissolving pulp also give a soft texture of fibers that will be able to, for this dissolving pulp to be wipes for baby wipes and facial wipes, because it have a surface that is smooth. The next is the seventh is the advanced application like nanocellulose and 3D printing materials. A nanocellulose is a material derived from dissolving pulp for use in lightweight composite, electronics, and medical devices. So the next is 3D printing material, used as a base of biopolymers in advanced manufacturing. As we know, as the growth of the universe and the growth of the technologies, will be using the 3D printing materials and will be used biopolymers in advanced manufacturing also, so that in this case dissolving pulp also will be used in the 3D printing materials. Okay, that's all from my explanation about dissolving pulp, not only in the pulp and paper industry, but also this dissolving pulp will be globalization, and then this dissolving pulp also have many using in these industries, not only in pulp and paper industry but also in textile. So if there anything wrong from my explanation, please be free to correct my words. Thank you from me. We'll see you in the next one.